There are many good videos on YouTube about Kafka, so why am I making yet another one? Well, this will be slightly different, in which I'll be going through each of the Kafka concept with live working example, with no added complexity so that to keep it purely simple and beginners friendly, so you understand everything clearly. And when I started preparing for this video, I realized that there is a lot to cover, so I decided to break it down into chunks, so hence this is going to be a first part in the series, in which I'll be covering the followings. A quick Kafka intro, what it is, why big companies like Netflix, Uber, and many more use it, and how. I will prepare a small Kafka cluster in my local machine using Docker along with the Kafka UI so you can actually see what's happening inside the core components like broker, producer, and consumer and topics. Then I will write and run a basic producer and consumer Python script and observe how data moves in the topic just to get comfortable with the basic flow. Then we'll move ahead understanding the topics in a bit more detail, especially diving deep in the topic offsets, partitions, why you would need more partitions, and what benefit it brings. And the last concept in this video will be to understand the basics of message formats, schemas, and structures. So we'll look at how Kafka Broker distribute messages across the topics with the multiple partitions, especially the difference between when a message is sent with and without key. And finally, in the end, we will answer some frequently asked questions. So let's get started. Right, so quick intro. Apache Kafka is a distributed event streaming platform that lets you move the data between the systems in real time at massive scale. It comprises of mainly three components. Firstly is the broker, and there can be many brokers, which handles the data flow from producers to consumers. And what you see on the left side are the producers, the second component. Messages can be streamed across multiple sources from producers, including IoT devices, mobile apps, databases, and literally whatever you can think of. And the third component is the consumers, the application which ingests this data to do something meaningful. Here is I mentioned down the list of qualities that Kafka has. And wait, yes, I know. You won't understand these qualities just yet. I just mentioned them here just to make you aware that this is the reason why big companies like Netflix, Spotify, Uber, and many other modern data-driven companies use Kafka. So don't worry, every single list of qualities mentioned here will make complete sense once we walk through these demos. So make sure to stick around till the end. You'll see each of these traits in action, not just as a theory. So here is a simple Docker compose file that I have built for my local machine, and I'm running this in my Mac machine, and the provided images should run on Windows and Linux as well. I'm using Kafka version 4.1.1, which is almost the latest one by the time of I'm recording this video. And this does not require an additional component, which is called Zookeeper, which was required in the older version of Kafka. So that acted as a brain for the Kafka brokers. But in the modern versions of Kafka from version 3 onwards, they have introduced this called kraft mode. So basically this removes the Zookeeper completely and lets Kafka manage its own metadata internally using the built-in draft consensus protocol. And I won't go into the much details of that, but for now, I will recommend you to use this new version of Kafka where you have one less complexity of adding an additional Zookeeper service on top of the Kafka brokers. I won't go into too much details here, except few things like Kafka Broker will be available on localhost on 9092 port. And I'm also spinning up a Kafka user interface app, which is provided by these guys. And we are providing here the Kafka address for this UI to connect to Kafka brokers, and the UI will be available on port 8081. So that should be pretty much a simple Docker compose file. So let's go ahead and run this. Just go to the directory where your Docker compose file is, and from there you just type in Docker compose up. This should spin up both of these services and will take a while to finish completing. So let's wait.
A few moments later.
Right, seems like Kafka is ready and the Kafka UI is also, looks like it's ready. All right, let's go ahead and go to the browser and access the UI. Right, there you have it. It took a while, but yes, it's now ready and it can see the cluster. You see one cluster is up and running and it's online. And remember, for this setup, we are just using one Kafka cluster to keep it simple and minimal for beginners friendly purpose. But later on, we are going to also demo multiple Kafka clusters as well. So that will be for the later videos. All right, so you can click on brokers and check out the status of the broker. And you can go ahead and click on topics. Currently, you won't see any topic yet because we haven't created any. And if you have an active consumers, they are going to come up here. All right, so let's go ahead and write a very basic Python app that's going to produce some messages for us in a specific topic. Now, there are different packages and libraries available in Python to interact with Kafka, like Confluent, Quick Streams. But for this tutorial, we are going to use the simplest one, which is Kafka Python. So this is how the producer code looks like. So you define the producer, you provided the Bootstrap server address, in this case, localhost 9092. Since the messages in the topic moves as bytes, so this is going to serialize and deserialize the message for us automatically. And then I'm using an example of IoT scenario here where we have, let's say, three sensors on the field, sensor A, B, and C. And we choose the topic called temperature data. And sequence number is just another index which will increment. This is going to help us see what the number of messages are coming through in the topic. And then we have an infinity while loop where whenever we are going to press enter, it's going to send a message. And we select any one of these sensors randomly and we construct a message like this. So we add a sequence number, sensor ID, and a random temperature and a timestamp. And finally, producer.send the topic name and the message. And we increment the sequence number and we log the message. Right, let's go ahead and run this. I'm going to press enter and this should send a message. Voila, okay, great. Now, one thing to note here is that Kafka will automatically create a topic which it has not seen before. So in our case, temperature data should now be created because we have sent this message. Let's go ahead in our UI and click on topics, and there you have it, temperature data. You can see currently it has one partition and that's by default. And the number of messages here is 1. Let's go ahead and click this topic and look at the messages. There you go. This is the message that we send. All right, so far so good. Let's move ahead to the consumer side and ingest these messages. And again, yet a very simple example of consumer topic temperature data, and we construct a Kafka consumer class, mention the topic, Bootstrap server, and auto offset reset to earliest means that it's going to consume the messages from the beginning of the topic. And enable auto commit is true. That means this consumer is going to tell Kafka that I have consumed and committed this message. So next time I'm not going to read this message in the topic again. Right? So then we are running a for loop and consuming all of the messages within that topic. Let's go ahead and run this. There you go. You can see our consumer has listened to the topic that we just sent from the producer. If you go to the UI and go to consumers, you will see nothing over here. And that is because of the reason. Right. So let's go back to the code, and you see enable auto commit is true. So technically that means that if I run this consumer again, it should not consume this message again. Let's see. That's not true. You see, we restarted the consumer. So in a real world, for example, if the consumer crashes for any reason, it's consuming the message which it has already seen. So this can cause duplicates. So why is this happening even we have set it enable auto commit true? That is because we are not assigning any group ID to this consumer. And by default, the group ID is none. So what that means to Kafka is that every time you start a consumer with no group ID, Kafka says, this is a new anonymous consumer. So where should I start consuming the messages from the topic? It sees that auto offset reset is set to earliest. That tells Kafka, okay, so I'm going to start from the beginning. And that is exactly what's happening here. Now let's go ahead and add a group ID over here. In this case, we'll just say topic name dash group and run this again. Right, so now we have a consumer with a group ID. Now the Kafka knows that this consumer group ID has read this message from the topic and it has auto committed as well. And I can show you in the UI as well. So if you go to consumers, voila, you can see already we have a consumer group mentioned over here, and the consumer lag is 0. That means that this consumer is already caught up with all of the messages in that topic. So just click this consumer and you will see a bit more details here. You see it's saying that this consumer is linked with this topic. And the offset here refers to the term like you can think of as a checkpoint. Because this topic has only one message, so the offset is 1 and end offset is 1 as well. So let's go ahead and send some more messages from the producer and see how this consumer behaves. So I go to producer and just click enter and enter. So we have sent 2 more messages from this producer, and go ahead on the consumer and you can see it has already received those 2 messages. And from the UI, you can see the offset has increased to 3. End offset, which is the end of the topic, is also set to 3. And the lag is 0, which again means that this consumer is caught up with all of the messages in this topic. Right, so let's stop this consumer and send more messages on this topic. Right, so this topic now has 2 more messages over here. Now, if you go to the consumer group again, you will see the consumer lag is 2. That tells that there are 2 more messages in this topic which are yet to be consumed by this consumer. The current offset of this consumer is 3. That means it has read 3 messages so far, this, and this. Whereas the latest offset of the topic is 5, which is still here. And now let us go ahead and run the same consumer with the same group ID again. And this time it should receive only 2 new messages which have appeared on that topic. So let's go ahead and see that. There you go. We are receiving only the new messages in the topic because the previous ones were already auto committed. And on the UI, you will see the lag again goes to 0. And the current offset of the consumer is equal to the end of the topic offset, which is 5 in this case. So before we move on to the next topic, a quick note on these two settings, auto offset reset and enable auto commit. So basically Kafka consumers keep track of where they left off by storing an offset, which I just showed you. Enable auto commit equals true, and that is the recommended and by default behavior, in which Kafka will automatically commit the offsets every few seconds as soon as it has received the messages in the background. And the advantages of this is that obviously you do not need to write a separate code line for this to commit the message, and it's safe for most real-time applications. And if the consumer restarts by any failure or anything, it continues near where it left off. However, there may be some cases where you may want to turn the auto commit off, where you are telling Kafka that I'm going to handle offset commits by myself. And this is only needed when you must commit after some expensive processing, or you want a tighter control like exactly once with the database transactions, or you need to avoid processing a message unless the downstream system finishes successfully. And if you use this manual commits, you must commit offsets gracefully. Otherwise, the consumers may reprocess the old messages. Whereas for auto offset reset, this option is only applicable where you have no committed offsets before. For example, this is the first run for this specific consumer. The two options here are earliest, which starts from the beginning of the topic, and the latest, which starts from the newest message in the topic. And this latest is the default behavior. But let's say what happens if you want to backfill the data from a given topic. So in this case, enable auto commit is true and the auto offset is set to earliest, will not help you backfill because the consumers have already committed the offset stored in Kafka. So Kafka will resume from the committed position, not the earliest. So the best approach to do the backfills to read the older message from a given topic is to use a new consumer group with a new group ID. Let's say call it as the topic name dash backfill, and keep the same settings for auto offset reset to earliest and enable auto commit to true. And in this case, now because Kafka sees no offset for this new consumer group, it is going to start from the earliest. Now you may be asking a very common question. How long does a message stays within a Kafka topic? Well, Kafka does not delete a message after a consumer reads it. And that's what we have seen already. So multiple consumers or even a restarted consumer can read the same data again as long as it's within the retention window. Now, what is a retention window? So Kafka does not store the message forever by default. It stores them based on the retention policy. So every topic has a retention time, for example, 24 hours, 7 days, or even months. And as long as that time hasn't passed, the message stays on the disk and available on the topic, no matter how many consumers have read it. You can also configure retention by disk size, not just by time. For example, keep only the last 10 GB of data. So yeah, in short, the message stays in the topic until the retention policy removes them. So not based on whether they were consumed. Alright, so that wraps up the first part of this Kafka series. Just to recap, what we have covered so far are the absolute essentials. A quick intro to Kafka, its core components. We set up a lightweight Kafka environment locally, along with the Kafka UI. And finally, we wrote a first producer and consumer Python script, sent some messages through the topic, and saw how the offset works and how consumers decide where to start reading from. And if you have made it this far, you have already built the core foundations you need. Because before understanding the scaling, partition, performance, and all that fun stuff, you need to be comfortable with how a single producer and consumer works with a single topic. In the next video, we are going to dive deep into one of the Kafka's most important concept, which is topic partitions. We'll understand what they are, why you may need more partitions in a topic, and what benefit it brings, and many more. And also we'll be looking at message structures, like how Kafka distributes the messages on a given topic with multiple partitions. We'll look at the different formats of the messages, like with and without keys. So with that, let's call off this video over here, and I hope this was informative for you guys, and if it was, don't forget to like, share and subscribe. And if you have any questions, feel free to mention them down in the comments below. I will be reading each of the comments and will be responding as soon as I can. So until next time, thank you so much. Bye.